All right, so Mike Perm's a really nice guy, and he bought me dinner at RubyConf, so I thought I'd try to pay him back somehow by contributing to his project, Sidekick. But the problem is, it turns out that Mike knows way more about threading and concurrency than I do, so I couldn't find anything meaningful to contribute on Sidekick. But I do know a little bit about web performance specifically, so I thought I would help him out by making sidekick.org load a little bit faster. So I'm just going to explain some of the changes that I made and how I went about discovering what to do and deciding what to change. So the first thing I do when looking at a website is get my big dumb face out of the way. And I open up Chrome, but I open up an incognito window. And that's not because I don't want to be seen. I want to get my browser extensions out of the way because incognito doesn't load any of your browser extensions. And since browser extensions are just JavaScript that executes on every page load, that'll screw up any of the profiling tools that we want to use. So use incognito, get rid of those Chrome extensions, pop open developer tools, and let's go to sidekick.org. So I used to use Timeline a lot more. I'm actually starting to use the Network tab more nowadays in Chrome when looking at this stuff, just because 80% of the performance issues on web pages now, especially if it's not some fancy JavaScript single page application, are not in JavaScript or in something that you could really find in Timeline. It's in the network. It's in when the resources are downloaded. It's in what protocol you're using to download the resource. So I'm actually starting to use network as my sort of first tool of choice nowadays. I have some preset throttles in here. I have a very fast internet connection at home, so I throttle down to some numbers that Akamai says are the world averages. So this is an open source project. People use it from all over the world, so a global average number is appropriate here. That's 5 megabits per second with a 40 millisecond round trip time. So I'll just reload the page with the network tab open, cache disabled, and that throttle on. And we get a DOM content loaded in about 400 milliseconds. Let's just keep loading to see. And yeah, and a load time of 650. Let's blow this all the way open here. Put my face up here. So the first thing that you're going to notice when looking at this network timeline, oops, I have images only open here. Let's look at all the resources. Is there's a lot of these empty bars here. And what that is in Chrome Network Tools is it's just showing you how long it's spent queuing, waiting for this request to start. So in HTTP 1, we have a limit on the number of connections we can have between one host and one browser. Or sorry, one host and one client. And I'm not sure if this was limited in the spec originally. I think it might have been. It might have been limited to 2. And I don't know if it changed in the spec, but browsers have definitely started upping that limit. So I think in Chrome now, it's 6 connections per host name. Mike is serving 18 PNG images on this site or thereabouts off his sidekick.org hostname. So those are blocking and downloading 6 at a time, and then the next 6, and then another 6. So that's one problem here with some of the image loading that I'm going to try to look to fix. And that seems to be kind of the majority of the time spent downloading. The font downloads start a little late, so I'm going to be interested in that. Oops. Screwed that up there. And we've got some JavaScript here. So GitHub Pages serves their resources with a cache control of max age 600, which is, 10 minutes. So that's not very good. We'd like to get that behind a longer cache lifetime, especially this vendored library here. This looks like an app-specific JavaScript file, so I'm going to leave that the way it is. And we've got some jQuery downloading here and a global CSS file. So those font downloads are going to be stuck behind how fast this globals.css can download. The reason for that is because the way browsers load web fonts is that they wait for the CSS on style sheets on the page to load and the DOM to finish loading. So that's the DOM content loaded event. Then from that, they build what's called the render tree. And the render tree contains all this information like, okay, we're going to render these letters in XYZ font. Then the browser looks at that and says, okay, I only need XYZ characters of this font. And then it goes and downloads only those characters that it needs from the font resource, if it's all supported. So the browser will wait until that CSS is downloaded and parsed before actually doing the font. So to get that font load speed faster, we're going to have to look at speeding up the CSS download because it's going to be blocked behind that. So the second thing that I do, now that I've got an idea of what I'm looking at here and sort of where the optimization opportunities lie, is if it's a simple page like this one, and there's not a lot of like third-party JavaScript being loaded in, I can wget with the P and the K options. I think I need this here. And I can download the whole page with its sub-resources, with its JavaScript, whatever, and it'll change all those links into relative links so that I can look at the page as if it was online, but I can serve it locally. So then I can download 2 copies and then make one copy the one that I sort of modify and optimize, and then I can check the changes against another local copy. This is great because if I was comparing a local version against the version on sidekick.org, that might not be 100% one-to-one because I can't set up basically locally a file server that will work exactly like whatever GitHub Pages is using. So I'm just going to make it one-to-one by having both of my copies that I'm sort of the reference version and the version I'm optimizing local. So I'll use wget to do that. I've already done that here. So I've got an optimized version or the one I'm going to work on and then sort of the original. I use a node-based web server called Static, just because Static seems to be the only of these like one-line web servers that also can gzip some content. That's going to become important in a second, why I can do gzip here. And I put it up on localhost on the ports 8000 and 8001. So let's take a look at those. So this is the original version of Sidekick loading locally. And this is my post-optimization version. So let's talk about what I changed. Just going to pop the source here. And I'll bring up, let's see, let's do this. Can I change this? Yeah, sweet. So the first and most important thing, usually what's slowing down page loads nowadays is JavaScript. Not the actual execution of it, although that definitely hurts you too, but the downloading. So when a browser is parsing your page, it's going to see a script tag, and if it doesn't have an async or a defer attribute, it has to stop, download the script, and execute it. So you can imagine on if this jQuery file, I know it's not that big, but if it was 300, 400 kilobytes, that could take a long time. So he's got 4 JavaScript files here in a row. They're on 2 different CDNs. That's also going to slow us down a little bit because we have to open up and negotiate SSL for 2 different hosts. So I'd rather have them on the same CDN, so we only had to have one SSL connection, and even better if we had an HTTP to CDN that would serve both of these assets. It's a jQuery and a Bootstrap vendor JavaScript. So I was able to find that there's a Cloudflare enabled CDN that lets us do that. Another thing here I'm going to notice is that the Google Fonts CSS is being loaded over an insecure connection. If you add just a little S here to the HTTP connection, you'll notice that, oops. So originally, get my face out of the way again. when we download the, oh man, this size seems to have screwed up the UI here. Now I can't change where that is anymore. It's downloaded over HTTP 1.1. So you may have heard that HTTP 2 doesn't require SSL. That is true, but the browsers have all agreed to not implement that. So to use HTTP 2 in a browser, you must use SSL. So by just adding a little S to our Google Fonts link, we can get our fonts downloaded over HTTP 2, which is a nice little benefit. It doesn't actually really make this particular situation any faster. Again, I should have done it here to begin with, but I'm going to make sure I throttle here too. And I already talked about the scripts, so I'm going to add a defer attribute to those scripts as well. I'll just show what that looks like. Just adding a defer attribute. And the reason I'm going to do that is to take the scripts out of the document parser's flow. So it can just blow by those scripts, and it will only execute them once the rest of the DOM content has already been parsed and loaded. So that just is going to speed up the first paint time, because we can start painting then as soon as the CSS is downloaded and been executed, and then the DOM has been parsed and loaded. Before, we had to also wait for the scripts to execute. Now we don't have to wait for that. And that you can see that effect on timeline. So this is the optimized version. Painting starts at 279 milliseconds. On the non-optimized version, I'll start at 447. So the reason I did this, and I couldn't use the async attribute because these scripts need to download and execute in order. Like Bootstrap requires jQuery. So rather than doing some like Webpack, AMD, JavaScript way of solving this problem, I'm just going to do it with the script tags. So we need these scripts to still execute in order. The async attribute, they will download, but they will execute as soon as they are done downloading. So that could happen out of order. This Bootstrap JS could download and execute before the jQuery script downloads and executes, and then that'll break because Bootstrap doesn't have jQuery ready. The defer instruction will, in theory, execute these JavaScripts in order. It will just execute them later when the DOM content loaded event happens. There is a problem with the defer attribute in IE8 and below. They don't always execute in order. You should also know that if you have inline script in the page, that will not execute in order. So the inline script will always execute before the deferred scripts. It used to be, I think, that you could make that, or it was sort of, people couldn't agree on whether or not it should do that. Inline will always execute first now. In this case, it works because Mike doesn't use inline JavaScript, so there's no problem. So I think, the other thing I noticed was that Mike was loading the Glyph Icons. This is the font that comes with Twitter Bootstrap off his own domain, and it was a WAF format font. Where does it say that? Yeah, .waf. So two things were wrong with that. One, it's off GitHub Pages, so the cache control header is awful. It's actually not that bad. It looks like it's actually different. Oh, this is my local version, right? On actual GitHub Pages, it says max age is 600. So if someone goes to sidekick.org, goes back later, they have to re-download the font, which is not optimal. So I want to move that to a CDN, which I was able to find a CDN hosted version of this font. The other thing is that, so it doesn't help much in this case, but there's Google has a font format called WAF2, which is just the WAF format with a different encoding, a different content encoding, different compression algorithm. It uses Brotli, which is a sort of like hopped up gzip. So you can see that here. It's over HTTP2 again. It's a WAF2 format font. And it's the same font. It's exactly the same. But the WAF2 version is about 4 kilobytes smaller, which is 20%. On a bigger font, this obviously makes a bigger difference. So it's kind of an academic exercise here with Sidekick. The really only big change that I was able to implement here that makes any difference really to the average user was deferring those scripts so that painting can happen quicker. And putting more stuff behind CDNs is always a good idea for repeat users. So I think that's pretty much all I changed. So yeah, I hope you learned something about using the network tab and throttling and looking at Chrome Timeline.